디지털 제너레이션 얘기가 있습니다. 블록체인의 어떤 학자의 관점에서 말씀을 해주시겠습니다. 프로페서 please come to the stage. 큰 박수로 환영해 주시기 부탁드리겠습니다.
Much better. Okay, thank you very much. I am a lawyer and a computer scientist by training, and have been working and studying as both for quite some time. And in that period, I have learned, as we have seen many new technologies come to fruition around the world, that it is important, very important for society, that we all have an adequate understanding of the technologies that emerge before those technologies become part of our society, so that we have time to make decisions about how we want to handle the challenges that new technologies will bring. And so my presentation today has three goals. The first is to educate our general audience about what we mean when we're talking about these concepts of blockchain and artificial intelligence. The second is to talk about what are some of the implications, what are some of the new technologies, some of the new economic implications that will come with the implementation of these technologies. And then lastly, to point out some key issues that our governments, that our leading scholars will need to think about as we move forward in dealing with this new, emerging, and groundbreaking set of technologies which are coming into the world at a pace far faster than we have ever seen before, even faster than the pace it came into being. So we begin with a discussion of what is blockchain. Now, many people have heard of blockchain. Many people have heard of Bitcoin and other cryptocurrencies, and we just heard a wonderful keynote discussing how blockchain can be used. Something that I think often is overlooked in these discussions is some general understanding for the non-computer scientist, for someone who is not an expert in these technologies. What does blockchain really do? How does it really change and affect my life? Blockchain is both incredibly simple and incredibly complex at the same time. It is incredibly simple because it really is nothing more than one really large ledger. But it is incredibly complex because the way in which that ledger operates changes the way that we think about certain questions in law, and it changes certain fundamental assumptions about macroeconomics, which we have held to be true, perhaps even immutable, unchangeable, for decades, if not centuries. So a blockchain comprises a ledger, a list of things, and it's a list of digital assets. That is maintained through something called a consensus protocol, which allows the network to distribute all around the world the process of verifying and determining that the ledger is accurate. I use the term distributed verification technologies, or DVTs, to refer to the larger category of technologies, of which blockchain is one example. And the reason that I use this is because blockchain is the first version. Blockchain, or Bitcoin, is version 1.0. It just tells us the beginning of the potential of these technologies. It allows for things like continuous verification of data, the decentralization of the authority that verifies that data, the ability for real-time consensus operations to reach real-time agreement in the digital space, and provable data integrity, which means that anyone can ask the question of one of these DVTs, of these technologies. Anyone can ask a blockchain, who owns this token? Who owns this coin? What is the state of this contract in Ethereum? And the network will provide back an answer. And in computer science, we can show mathematically that the probability of that answer being wrong is so infinitesimal that it doesn't matter. To better understand why we need to think more broadly about these technologies, I want to talk about the two essential core elements of blockchain, but more broadly of this category of technologies of which blockchain is only the beginning. The first is this concept of distributed data processing. Distributed data processing is not new. We have known about it in computer information and information science for decades, if not longer. But it's really hard to do. You heard a little bit about some of the challenges involved in this from our first keynote speaker. The blockchain concept has created, through the use of consensus mechanisms, a method by which we can do distributed data processing in a way we could not do it before. So if there are two core elements that make up a distributed verification technology, it's the ability to distribute the processing and storage and management of data, and to have some mechanism or protocol for reaching consensus, for answering questions, for deciding what is happening with that data. Here's some examples to show you the broader picture of distributed verification technologies. I imagine everyone in the room is familiar with blockchain and probably Bitcoin and Ethereum. There are other types of distributed ledger technologies. The EOS project is one example, and I'm sure many of the folks in this room could name others. All of these generally use something in computer science that we call a linked list. I'm not going to explain what a linked list is in the interest of time, but I'm going to tell you that it is a type of data structure, a way of storing data, that is very inefficient, it's very slow, and it requires a lot of computing power. Imagine if the things that we call blockchain used more advanced data structures. For example, a graph. Something that allows you to look through the list rather than going in order. You have a list of 1 million lines long. Imagine trying to find a library book if you have to look at the title of each book one at a time until you reach that book. Imagine that you now have a way to go more quickly directly to the book you're looking for. That's the idea behind a graph implementation. This larger category, this forward thinking about what types of blockchain technologies can bring about, will bring the type of evolution where we will see the advantages and the legal and social challenges that come with a world that relies less on centralized authorities and more on the creation of an autonomous distributed network. So I'm going to walk you through my vision of blockchain 1.0, 2.0, which we've seen today already, and then blockchain 3.0, which is